Hello friends, welcome to the ATC Double Cut. My name is Michael Woods. In today's episode, I am going to talk about a new post on the ATC website, and this one is, like many things that I work on, something that was inspired by and prompted by, and something that I decided to try to study some more because of a real world problem, because of a problem or a question that we had in turfgrass management on real professionally managed turf. It's not just an academic question or just something that I was curious about. It's something that I started studying because I thought, here's a problem that I need to solve. I suppose that's how most turfgrass research happens, but it occurred to me that a lot of the things that I work on tend to be in response to something that I don't know how to do, and I decide to figure it out. So this one I'm excited to share with you. It is a blog post that I'll put a direct link to in the show notes so you can check it out. The title is Reconstructing Soil P from Disassembled Soil Samples. I want to explain what I mean by disassembled, and I want to explain how I reconstruct the soil P, and I want to explain what this is all about, because it's about doing soil testing in a way that will allow you to get even more value from it. It will allow you to get even more actionable information and make better decisions and make decisions with more confidence based on your soil test results. I started off this post with some text that said, "This is one of the many interesting things I've been working on recently. A standard soil test for turfgrass is taken to a 10 centimeter depth or 4 inches below the soil surface. But there can be large differences in soil properties within that 10 centimeter depth." And that is correct. You will see large differences in soil properties because the grass is growing right at the surface, and some of the nutrients that we supply are relatively mobile, so they can move down through the soil. Other nutrients are relatively immobile, so they will tend to be bound to the soil particles close to the surface wherever they come in contact with the soil particles. And you also have a gradient of organic matter accumulation from the grass that's growing on the surface. So that's going to cause changes in cation exchange capacity. If you're applying fertilizers that have a tendency to acidify, and almost all nitrogen sources eventually will tend to acidify the soil. So where the grass takes those nutrients up from the root zone, and you will have more roots near the surface. So where the grass is taking up those nutrients, that's where the acidification takes place. And if you're adding liming materials, then those are going to react where they are reacting, where those actual calcium carbonate or calcium magnesium carbonate molecules are. So a lot of things are happening at different locations in the soil. And a standard soil test, remember, is going down to a 4-inch depth or a 10 centimeter depth below the surface. That's standard for turfgrass. I recommend that everybody do that, sample to that depth, unless you have a really good reason not to. And I put a footnote in there in that blog post, and the footnote was, if you're in New Zealand, you probably have a good reason not to, because I understand that the standard in New Zealand, as recommended by the NZSTI, is a 7.5 centimeter or 3-inch depth. Now, I prefer 4 inches or 10 centimeters because most turfgrass has roots that go down to 10 centimeters. So I don't really see a reason to cut off arbitrarily at 7.5. Now, I cut off arbitrarily at 10 centimeters, but I think that is a better estimation or a better approximation of the turfgrass root zone than is 7.5. But if you have a national or regional database of samples at a particular depth, and everybody's doing it at that depth in your region, then it makes sense to stick with what you're doing. And so that is an excellent reason. That is an example of a really good reason to adjust from what I recommend. So let me tell you the story about how I started getting interested in this, because I only started doing this a couple years ago, and now I'm recommending it. I'm recommending this for all of my clients. Not all of the samples, but for some of the samples, I recommend to take these disassembled soil samples. Here's the story. I was doing soil testing at a particular property for many, many years, and let's say over a decade. And the soil had been fertilized with a lot of phosphorus, and phosphorus is relatively immobile in soil. So this location had a soil phosphorus level on the Mehlich 3 test of about 200 parts per million about 10 years ago when I first started doing the soil testing there. 200 parts per million on a Mehlich 3 test is quite high. It's more than ample for putting green turf of any species. And so my recommendation was don't apply any phosphorus this year. And then the next year, it's like 170 parts per million phosphorus on the soil test. So again, my recommendation was don't apply phosphorus this year. Keep in mind that the Mehlich 3 MLSN value for phosphorus is 21 parts per million, which means we want to stay above 21 parts per million in the soil if we're going to ensure that we're not going to have any risk of a deficiency. And so I continued this year after year, and the soil test phosphorus went down to 140 and 130 and 120 and 70 and 60. And after about 10 years, the superintendent asked me, he's like, hey, I've got a few spots on my greens that are not looking so good. Do you think it could be a phosphorus deficiency? And I said, no. Well, let me check your soil test. So I went and checked the soil test from the previous spring, and the soil test phosphorus was something like 60 parts per million. And I told the superintendent, I said, well, it's almost certainly not phosphorus. You're not only well above the MLSN value, but you're more than double it. It's really, you're like a totally average value for P. This is what the average value for P for putting greens is all over the world. Something in the 60 part per million range for the Mehlich 3 extraction. And then the superintendent told me, he said, well, but my roots are really shallow and I have more roots near the surface, and I haven't applied any phosphorus for years. And do you think it could be that the phosphorus is depleted at the surface, and then what you're measuring on the soil test is just phosphorus that's down below where most of the roots are? And I thought about it, and it didn't take me, it just took a couple seconds to realize maybe he's on to something. Maybe there is an issue. So I immediately said, okay, let's do a test. So I said, please go to the bad areas, the areas that are weak on some of these greens, and I want you to take tests in a special way. Please take samples to a 10 centimeter depth, but cut them at the 5 centimeter mark, which is 2 inches below the surface. So cut the sample in half. Take the sample to a 4-inch depth, cut it at 2 inches, and put it in 2 bags. So you're going to have a bad area sample, and it's going to be split in 2. The bad area sample is going to be a 0 to 5 centimeter depth sample and a 5 to 10 centimeter depth sample. And on that same green, I want you to go to the good area and take the good area sample and split it also, and look at the top 5 centimeters and the bottom 5 centimeters. And do that on multiple greens, please. So the superintendent did that, and the superintendent sent those samples to Brookside Labs, and those got analyzed, and there was a very large difference, as the superintendent expected, between the phosphorus content at the top of the root zone and the phosphorus content at the bottom of the root zone. So specifically at that property, at the top of the root zone, the Malic 3 phosphorus was about 30 to 35 parts per million. That's what it was at the top. And in the bottom 5 centimeters, it was 120, 130, something like that. So there was a 400% difference in soil phosphorus by depth. And that, of course, the average comes to 60 or 65 or 70. But there was only 30 at the top. Remember, that's still above the MLSN minimum. And then there was 120 or 130 down in the bottom 2 inches of the root zone. So it was really interesting to check that and to confirm that, yeah, you definitely have depletion of phosphorus at the surface, but I still think there's enough for the turf. I don't think that your bad turf on these greens, I don't think those bad areas or thin areas is being caused by a phosphorus deficiency. But because you have so much depletion, and just to make sure that that top doesn't drop down below the MLSN minimum, let's go ahead and make a broadcast phosphorus application to these greens and make sure that there is plenty of plant available phosphorus in the root zone. So that was the recommendation, and we moved on from there. But now I recommend this for everybody. And I want to explain a little bit about why I recommend it for everybody and show some more data from this particular blog post that shows just how interesting this is and how you can go back to reconstructing your soil phosphorus. And you can reconstruct a lot of soil properties at the 0 to 4 inch depth or 0 to 10 centimeter depth. You can reconstruct them from these disassembled soil samples, from these soil samples that are split in two and submitted as 0 to 5 centimeters and 5 to 10 centimeter depths. So the reason why I recommend this for everybody is because if we don't check this, we don't know. And I think for phosphorus in particular, this is one that a lot of people are doing interesting things with. If you're managing creeping bentgrass greens or fine fescue greens and you're trying to keep Poa annua out of the green, or you're trying to minimize Poa annua invasion, then it makes sense to keep the phosphorus as low as possible as fertilizer. But you don't want the phosphorus to get so low that it would limit the turfgrass growth in a way that turfgrass quality would go down. So to understand that, it's useful to know where in the soil the phosphorus is that you're measuring. And ideally, you'll find that the phosphorus is lower near the surface, and you'll find that phosphorus is higher deeper in the root zone. Because if you're trying to minimize Poa annua invasion, it's nice when you have bentgrass roots that go down to 8 centimeters and there's phosphorus down at 8 centimeters and you have negligible levels of phosphorus in the top 1 centimeter, and in the top 1 centimeter, that's where your Poa annua would be germinating. So it's nice if you have the gradient that goes like that. It would not be so good if you had 100 parts per million phosphorus right near the surface and 20 parts per million deep down in the root zone, because then you have a lot of phosphorus near the surface where Poa annua could grow. So it's useful to check that. And then there's other things that happen, and I want to remind you about that. Other things that happen that are going to change by depth. There's organic matter accumulation, cation exchange capacity that is associated in sand root zones with the bulk of the organic matter content in sand root zones is associated with the bulk of the cation exchange capacity. So you can check where you can expect to see most of your potassium and calcium and magnesium and so on. by looking at organic matter content by depth. And you can check the pH gradients. And if you are trying to acidify the soil, or if you're trying to bring the pH up, you can get a more fine-grained look at this by doing this testing by depth. So I have recommended for the past couple of years that all of my soil testing clients submit 20% of their samples as these depth separated samples. The samples that are separated at a 5 centimeter or 2 inch depth below the surface. So the sample is just kind of split in half. You take a sample to 10 centimeter depth, cut it at 5. The 0 to 5 centimeter segment goes in one bag. The 5 to 10 centimeter segment goes in another bag. Of course, that's 2 samples, so it doubles the cost. But if you just do that on 20% of the samples, you can figure out what the trend is on all of the samples. And then you still get all of the spatial information, the spatial variability from submitting from multiple grains. So basically, if you're submitting 6 samples, here's my standard recommendation. My standard recommendation was always to submit from 6 greens for 18 holes. So that's 33% of your greens. And if you submitted 6 samples, that has a certain cost. Now I'm saying submit samples from 5 greens, not 6. But you're still going to submit 6 samples, because from 4 of those greens, I'm recommending you to do a 0 to 10 centimeter depth sample. And on one of those greens, which is 20% of the greens that you're sampling, I'm recommending to submit 2 samples. And those 2 samples are the disassembled sample that's separated by depth. And if you do that, you can figure out, where is the pH changing? How is it changing year to year? Where is the pH? Where's the P gradient? Is the phosphorus gradient going from more concentrated near the surface and depleted deeper in the root zone, or is it the other way around? Is there more phosphorus deeper in the root zone, and is it depleted near the surface? And if you like to submit a lot more samples, if you're one of those courses that likes to do half of the greens or all of the greens on an annual basis, then I'm sticking with that 20% recommendation. So I suggest that if for every 10 greens that you sample, do one of them at for every 5 greens that you sample, do one of them at in a disassembled way. For every 2 greens that you sample, for every 10 greens that you sample, do 2 of them. And for every 15 greens that you sample, do 3 of them separated by depth. So I think that gives a lot of valuable information. And the valuable information is, I think, it's especially valuable for phosphorus, for pH, for salinity, for those kind of things. And of course, if you're concerned with something obscure like micronutrient toxicities or something, you could also see where the micronutrients are. But in general, I think this is applicable for everybody for phosphorus. And what the benefit is, it allows you to make more confident decisions about whether to apply phosphorus fertilizer or not to apply phosphorus fertilizer, or how much phosphorus fertilizer to apply. So I mentioned in the post that we can reconstruct these, and we can reconstruct them because we know the depth of the 0 to 5 centimeter section. We know the depth of the 5 to 10 centimeter section, and we get an organic matter value for each one of those depths. Because we get an organic matter value for each one of those depths, we can find the bulk density of that layer, and we can use the bulk density to merge those back together to reconstruct the upper layer and the lower layer accurately with a proper adjustment for the bulk density or the mass of the upper layer and the lower layer. So we reconstruct that, and we can predict the 0 to 10 centimeter depth or full depth sample result from those combined 0 to 5 and 5 to 10 centimeter depths. The chart that I'm showing now, let's see, I'm going to change the screen. The chart that I'm showing now, for those of you who are listening, I will describe it. For those of you who are watching, you are looking at the Chocolate Hills in the Visayas region of the Philippines, which is a very interesting landscape. And they look like little chocolate drops across the landscape, but they're, I don't know, 50 meters high or something like that, 60 meters high. And there's lots of zoysia growing on them, a lot of manila grass growing on them. So I thought that is a nice setting to look at. And I've overlaid a chart. And for those of you who are listening, what I'm showing on the chart on the horizontal axis is the Malic 3 phosphorus combined, reconstructed from those samples that were taken by depth. From those disassembled samples, I've now reconstructed what the soil test result would be on the full depth sample. And I show on the y-axis or the vertical axis what the 0 to 10 centimeter depth test result was, because I did a project in Japan on 19 greens, 19 different greens, not at one property, but in multiple locations, multiple grass types, different soils in Japan. And consequently, there are different gradients of soil phosphorus and different soil properties. And some of the Malic 3 phosphorus was down around the MLSN minimum, and some of the Malic 3 phosphorus was up over 200 parts per million in these samples. And I put a regression line, a linear regression line that almost directly overlays the one-to-one line. So I'm comparing what are the data that I reconstructed and what are the real data. So the real data are the 0 to 10 centimeter depth, and the reconstruction is a prediction, and it is a very nice prediction. What I'm showing is it is a prediction that almost falls on the one-to-one line on average. So that means if we do a lot of these tests, we will be predicting something that is close to the actual test result. And I've tested this also for pH and for organic matter and various other soil properties, and we get that nice result. So when we do these samples by depth, not only do we get a chance to check the result by depth, but we also can use that as one more 0 to 10 centimeter full depth sample, checking some of the variability across the site. And it is really useful to know this gradient. I wrote in the post about some of the variation that I measured just in this small experiment with 19 different golf courses. I wrote in the post, I said, how much do you think the soil P as measured by Malic 3 extraction varied between the upper and the lower layers of the root zone? It depended on which course was sampled. From those 19 greens, the mean phosphorus in the upper layer of the root zone was 49 parts per million, and the mean phosphorus in the lower layer was 92 parts per million. So that the phosphorus on those greens on average was higher, or there was more phosphorus deeper in the root zone. That means it was depleted near the surface, which kind of goes against what we think, because most people in the turfgrass industry, I certainly thought this myself, I expected that phosphorus would be concentrated near the surface because phosphorus is relatively immobile in the root zone. So I would have thought that it would be higher near the surface and depleted deeper in the root zone. But on these golf courses, which represent some modern turfgrass management, it was the other way around. And it can be quite extreme. So one green had one green had 248 parts per million more phosphorus in the lower layer than in the top layer. And that's it's more than a 600% difference. 6 times more phosphorus deeper in the root zone than near the surface. It's useful to know that. It's useful to know the total amount of phosphorus, and it's also useful to know where it is. The top of that root zone was at 48 parts per million, and the bottom of that root zone tested at 296 parts per million. Another had 155 parts per million more phosphorus in the lower layer. That one was 65 ppm near the surface, 220 ppm at the 5 to 10 centimeter depth. And 14 out of the 19 greens tested had more phosphorus deeper in the root zone. 14 out of 19 had more phosphorus deeper in the root zone. But how are your greens? Do your greens have more phosphorus deeper in the root zone, or is it concentrated near the surface? If you just do this test one time, I would recommend doing it one time year after year, or doing 20% of your samples year after year to test it. Then you'll find out, and you'll know the gradient of things like salinity and phosphorus and pH and so on. And I checked, I was surprised that there weren't more that were concentrated near the surface. And maybe that just goes to some of the more modern putting green maintenance where greens don't get fertilized with 1-1-1 ratio fertilizers. You know, people don't put triple 15 on greens very much. I know in Japan sometimes it's common to put triple 15 or 888 type analysis fertilizers on tees, sometimes on fairways. And I think maybe in those kind of situations we would find the phosphorus might be concentrated more near the surface. The opposite direction in terms of where it was concentrated higher at the top, the most extreme one in this data set had 17 parts per million more at the top than it did at the bottom. So the highest one in the other direction, though, had 248 parts per million more at the bottom than it did at the top. So that is a post that I would encourage you to check out to see how things can be. And I really want to encourage you the next time you do soil testing, and if you are someplace where it rains in the summer, then I recommend doing the main soil testing in the autumn. The autumn, I think, is the best time because the grass will have received all of its fertilizer for the year. It would have taken up almost all of the nutrients that it's going to take up for the year. And because of that, the soil nutrient levels tend to be at their lowest. That's for places where it does rain during the summer. For places that have more of a Mediterranean climate where it tends to be really dry during the summer and it rains during the winter, in those kind of places, I recommend the best time for soil sampling to be in the springtime. But if you are in a place where you get some autumn rains, and in fact, I recently had a communication with someone in the Pacific Northwest about this. If you're in the Pacific Northwest, I think wait until you get the autumn rains, which usually are going to come in October, maybe in September, and hopefully before snow falls, which might be in November or December, and get the soil samples taken then, because that is going to then give you one more advantage. It gives you all winter to plan which fertilizer products do you want to use the next year, how do you intend to apply them, what are the formulations, what suppliers do you want to use, what type of products do you want to use. It gives you all kinds of time to figure that out. If you're testing in the springtime, you've kind of thrown away the entire winter of planning. And if you're testing in the springtime and you find out you need to apply some product, you suddenly don't have so much time to think about what you might do. And you might not make such a wise decision. So I think it's usually better, if you can, to give yourself a little bit of time for the planning. And if you're in a tropical place where you have a rainy season and a dry season, I recommend the best time for sampling to be at the end of the rainy season. And if you are in places where you like to test twice a year, then I would recommend either spring and autumn actually, I don't even want to recommend that. If you're in a place, with a year-round growing season, so if you're in Florida, if you're in somewhere tropical, if you're in someplace tropical, then do the start of the rainy season and start of the dry season, or that's the equivalent to end of the dry season, end of the rainy season. So do those 2 times. If you're only going to do it once in a tropical place, do it at the end of the rainy season, because then that's when your nutrients will be at the lowest. Then if you're in the kind of place where you have bad irrigation water quality and you want to test twice a year, then do it at the end of your dry season and end of your rainy season. So what you're trying to do is catch the soils when they're at their worst. Sample their soils when they have the most salt in it, and you're trying to test the soils when they're at the least amount of salt. So the 2 times of the year are decided by that particular thing. And if you're in, let's say, upstate New York, and you really like soil testing, but you have decent irrigation water quality, that's the kind of place where I'm just going to say, don't test twice a year. I won't say spring and autumn, just do autumn. I don't really see what extra value you would get from testing twice a year. So that is my recommendation. So I'm just going to mention one more thing. On the ATC website, if you go to the menu, you can find a newsletters tab on the menu. If you're looking at this on a mobile device, you'll get one of those ladder menus or sandwich menus that you can click to expand, and it'll show you what the menu items are. You can sign up for the ATC newsletters, and one of the newsletters that was sent just recently was the MLSN newsletter. And if you get that, then you receive that by email already. If you don't get that newsletter, you can sign up for the next one by signing up on the newsletters tab, but you can go to the MLSN project page on the ATC website. You find that under soil tests, in the submenu, you go to MLSN. And if you scroll all the way down to the bottom of this very informative page about MLSN, you can find the recent MLSN newsletters. You can find the full text of those. You can download them and read them. MLSN newsletter number 23 is the recent one that I have. That is the recent one that I've posted on the website, and you can download and read now if you did not receive it already by email. The MLSN project is something that we continue to work on. We continue to check these results against actual turfgrass performance, and we update you with things like the MLSN newsletters, which is now up to the 23rd one. When I started that, I think back in 2017, I started the MLSN newsletter, and it was maybe 3 or 4 times a year at first, but as the project matures, it's now something that I typically am sending out that newsletter just 2 or 3 times a year. And again, I'm posting those recent ones in the very bottom of the MLSN page. So that is a bit of information about soil testing and what I recommend. If you have any questions about this or would like to disagree or suggest something different, you know how to get in touch with me. You can do that. Preferably, the way that I like people to get in touch with me is by email, and you can find that information. You can find contact forms to get in touch with me on the Asian Turfgrass website, asianturfgrass.com. You can also get in touch with me through Pace Turf, which you can find at paceturf.org. And let me know how you appreciate this information and how it's useful for you, or let me know how I'm getting it all wrong and you think there's a better way to do it. I will be glad to hear from you either way. And with that, I will sign off now, promising to be back rather soon with another ATC Double Cut episode with more interesting turfgrass information on this show, where we tend not to ask our guests how they got started in the industry. I've noticed with a lot of turfgrass podcasts, it's funny that one of the questions is, hey, tell us how you got started in the industry. And that's what people often ask me when I'm a guest on a podcast. I'm like, man, haven't you heard that about me before? Don't you know how I got into the turfgrass industry? I'll be happy to tell the story again, but I hate to bore people by talking about that. So I always just jump right in to the turfgrass information, or try to jump right into the turfgrass information. So when you listen to this show, or when you watch this show, I hope that I'm providing some information that makes you think a little bit differently about turfgrass management, think a little bit differently about how you're doing some of the turfgrass management practices, and hopefully giving you some idea and some perspective on how you can continue to do it well, or maybe do it even better in the future. So now I will really sign off. For ATC from Trang, Thailand, I am Michael Woods. Bye-bye.